All right. Hi, my Algebra 2 people. It is day 6 of Unit 2. We're going to be talking about even and odd functions. And if you don't have your calculator next to you, go get it because you need it. All right. So what even and odd function means? It's just another way that you can classify functions. So like we talked about one-to-one functions, we talked about onto functions. This is another way that you can classify or group them based on their characteristics. So here, when it says a function is classified as even, we're going to write it in slightly weird way, but roll with me on this. If f of negative x is equal to the regular old f of x for every x value in the domain. Right? So if when you plug in negative x, it always comes out to be the original. That's what we'd consider even. If it's an odd function, then when you plug in negative x, it comes out equivalent to the exact opposite of f of x for every value in the domain. Right? So this is a way to write it using like function notation. We're going to talk about what does that look like in terms of when you look at the coordinate points, in terms of when you look at the graphs and so on. So that's what this first page is. We're really going to roll out like what would you expect to see. So that's why I wanted you to have your calculator on you, because with this first one, you're given f of x equals x to the fourth plus 2x squared plus 5, and it's asking us to look at it numerically, right? Which means let's look at a table. So what I'd like you to do is go into y1 and type in this equation. So whatever's in there, get rid of it. And so we can type in our x to the fourth power, and then plus 2x squared, and then plus 5. Oops. I typed mine into y2, but it doesn't really matter. All right. So when you go to the table of values, what I want you to look at are a couple of the values around the origin. So let me see if I can zoom in a bit so you can see mine. I don't know how well you can see that, but that's why if you have yours, then we're good to go. All right. So what I want you to do is write down maybe from like -3 to +3, the table of values that you're looking at. So I'm going to zoom back out so that you can see my paper. And I'd like you to copy down from your chart. So if here's xy, so -3, -2, -1, 0, and then 1, 2, 3. All right, so copy down those particular values. For any reason, if you don't have your calculator and you're trying to look at mine, I've got 104, and then 29, 8, 5, and then it goes 8, 29, and then 104. And of course, it keeps on going, but for that particular value, right? So what I want you to look at is that if we look at, let's say, -2, it comes out to be +29. If I look at +2, it also comes out to be 29. So what that means is for negative x, I get a y, and for positive x, I get the same y. Right? What that is a perfect example of is this right here. Then the negative x, when I plug it in, I get the same thing as if I plug in the positive x. So that is an example of an even function. So for plus or minus x, if it goes to the same y value, that is code for we are looking at an even function. All right. So if we think that this thing is even, what we want to look at, and now keep in mind, I didn't mean it just for one x value, multiple x values. So -1 goes to 8, +1 goes to 8. -3 goes to 104, +3 goes to 104. It's a consistent pattern, not just one particular instance. To do this algebraically, we're actually going to plug in what we said there. So if I write down what f of x is, so f of x is x to the fourth plus 2x squared plus 5. What we're saying is if we plug in negative x, if it's really even, it's going to come back to the original. So let's plug in a negative x here, plug in a negative x here, and then we keep the plus 5, and then we clean it up. So if I take a negative number and raise it to the fourth power, that's going to force it to be positive. Same argument here. And then that's not affected. So what we end up with is that f of negative x comes out exactly the same as f of positive x. Right? And because these are the same, so this guy here and this guy here, that's another way to showcase that these are an even function. So they're the same. I'm going to use a little 3 dots, therefore, even, all right? That's what we literally showed, is that f of negative x equals f of positive x. Check. All right. Last piece of that, graphically. All right, if we graph this thing, again, if you have it in your calculator, just hit zoom 6 or hit graph if you're already probably on that window. And then all you see is what kind of looks like this skinny little parabola. So if I just sketch over here, we'll say that looks pretty darn close right there. All right. So this is the initial function. That's f of x. We haven't messed with it at all. Right? So we know at this point, this thing is definitely even. What characteristics does the graph have? Right? Well, if you think about it, if some particular point, a negative xy point, comes out the same as a positive xy point, we've been talking about transformations. Transformation that would take something and just negate the x value or vice versa means that you're reflecting it specifically over the y-axis. Now, I'm not going to say that this thing is its own reflection, but what I can say is if it's a reflection over the y-axis, that means it has y-axis symmetry. Right? So we can say if the graph, or actually, hold on to that thought for 1 second. Oh no, yeah, let's write it this way. If the graph has y-axis symmetry, then it's even. All right, so there's that even conclusion again. So when we look at it, what did we see? All right, well, if I have opposite x values going to the same y, if I can literally plug in and show that negative x, f of x, excuse me, or f of negative x, geez, equals f of positive x, we're good. Or if it has y-axis symmetry, all of those are going to come out to produce an even function or help us classify that we have an even function. Right? So with that being said, if this whole first function was even, you could probably figure out right now what the whole second function is, but let's look at what characteristics it has. Right? So I'm going to kind of break my paper in half here. So over here was everything even. Over here, if we go to our calculators, so go ahead and get rid of that first function. Let's put this into our y equals, which maybe this time I'll actually put it into y1. So 3 and then x and then raise it to the 5th power. Oh, that's my puppy. It's very excited. All right, if we go and look at the table of values, let's write a few of those down. Morning, Teddy. All right. So if we look at like -3, we're at negative 726. If we look at -2, we're at negative 94. -1 is -2. We got 0, 0 here. 1 positive 2. 2 positive 94. And you start to get the deal. Right? So when you have a negative x going to a negative y and a positive x going to a positive y, this time both of the values switched. Right? So I'm going to say if we have negative x, negative y, and positive x, positive y, right, on the same graph, that is code. Hi, buddy. Hi.
You keep hearing your voice. And
I know.
Somebody else.
That's the pup. He's huge, but he's a big old baby, and so he could hear my voice. Sorry about that, guys. All right. And sorry you didn't get to see him. No, got to focus on math. All right. So if negative x, negative y, and positive x, positive y are on the same graph, that is code. All right. This thing is going to be odd. And you can see that happening in multiple places. -1, -2, +1, +2. Now, it doesn't always have to be 2 negatives together and 2 positives together, but it has to be the opposite signs. Because what you're literally seeing there, all right, is go back up to the definition, is if you flip the x, then the y should be flipped as well. That's what it really means there. All right? But let's actually show that algebraically. So here's our plane, or actually, yeah, let's take our f of negative x, right? So if we plug that in, excuse me, we're going to have 3 and then times negative x to the 5th power and then minus negative x, right? Because that's the left side. If we plug in negative x, will it be equal to the opposite of the original? All right, well, when you take negative x and raise it to the 5th power, it's going to stay odd, all right? A negative raised to an odd power stays negative. So this really becomes negative 3x to the 5th. And then negative of a negative here, that becomes positive, right? Is that the same as if we were to negate the whole thing? Well, that means we would negate the entire original function. So 3x to the 5th minus x, like that. Distribute that negative, we get negative 3x to the 5th plus x. Yeah, those came out exactly the same. If I compare this guy to that guy, they are absolutely the same. All right. So what we're showing, we're showing that f of negative x is equal to negative f of x. That's another case where we'd say, yep, that is literally like the definition of an odd function right there. Right? And then graphically. So last thing, go ahead and hit graph because you should have your nice window from last time. So if we go to sketch this, we know it hits at 0, 0. You could plot some exact points or just do the best you can. We don't really need to get super fancy here. Right? So we can tell immediately what's not happening. It's not symmetrical over the y-axis this time, right? But there is a symmetry to it. If you can think back to your geometry days, this has point symmetry about the origin. If we take a particular point and we reflect it through, it should land on the graph itself. A quick way to be able to see that is if I turn my paper upside down. So I'm literally going to turn this upside down, but I'm going to keep my calculator the same, or I could have done it the other way around. See how it still looks exactly the same? That is a way to spot when it has that point symmetry. And so because it's symmetrical specifically about the origin, we say that it has origin symmetry because the origin is the point that we're talking about. Right? So here we would say that this has origin symmetry. But how to spot it, right, is to say if the graph looks the same upside down as right side up, then it's got origin symmetry, and we can say it's an odd function. Right? So let's quick kind of highlight like what did we see here. So going back up here, you have opposite x's, opposite y's, both on the same graph. For this next one, we're able to show that if you negate the x, it doesn't come out the same as the original. It comes out the opposite. And lastly, if it has origin symmetry or point symmetry about the origin, you can think of it that way, then all of those, we can conclude that we are looking at an odd function. So it does help to either highlight or underline or kind of be able to rule out that like, hey, everything on the left, this is about an even function. Everything on the right, that's about an odd function. So I know it took us a little while to get through that first page. What we're going to do is practice some together. We'll save the rest for the next time we're in class together. So let's jump on over to the next page. So it says, consider the partial graph of the function f of x shown in the grids. So you kind of have like this little, almost looks like an absolute value, but it's probably just a piecewise. It's got little endpoints here. It says, sketch the upper half of the function if the function's even versus if it's odd. I love this question because you got to think about what do you know graphically about when it's even. It's an even function. It's got y-axis symmetry. So you can either take every point and think about reflecting it over the y-axis. So like the point 0, 0 would stay here, meaning it's invariant, the point 1, 2, 3, 1, 2, 3, 4, 5 would then pop over and land over here. Right? Or you could say the point 3, 5 means I also need to have the point -3, 5. Right? So you can look at it a little bit algebraically. So this point I can walk over and go 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7. Or I could have said, all right, well, this is the point 7, -2. So I have to also have the point -7, -2. So opposite x, so xy and -xy. That's what's going on when you have an even function. All right, grab your straight edge, finish up that graph. So ultimately it kind of looks like a big M here. And now you're going to play the same game for the second one. If it's odd, what's going on? All right, well, graphically, this is where you have origin, symmetry. So what that means is it looks the same upside down as it does right side up. That's usually something to kind of test after the fact. What might be simpler is to start with that little chart. And we know we already figured these out. This is the point 3, 5. And then this was the point 7, -2. And so in the case of when it's an odd function, not only does the x value switch, so does the y value. So if this is 3, 5, this would be -3, -5. So then we can go left 3 and down 1, 2, 3, 4, 5. And then this one, same thing, -7, and that flips to +2. So left 1, 2, 3, 4, 5, 6, 7, and then up 2. Who knew so much geometry could be hidden in Algebra 2? Love it. All right, so now if you take it and flip it upside down, it should look the same as it did right side up. Right? So you kind of get that same, whoops, totally off the page there. That helps. That same little zigzag shape. So it kind of looks like a backwards N or I don't know, Z, however you want to think of it. Okay, but that's what you have here. Right? So when it says describe the symmetry of the even and odd graphs, well, we kind of talked about it already. The even has the y-axis symmetry. The odd has the origin symmetry. All right, we're going to skip over example 3 and save that guy for class. So I'm going to write a little recap next to that one there. Okay. As for what's left in this, I only want to do 1 or 2 more, and then we'll save the rest for some practice. So on to the last page here. We're going to skip example 4. And I'd like to look at example 5 here. So it says, is the exponential function f of x equals 2 to the x power, even, odd, or neither? Right? Support your argument with either numerical or graphical evidence. So the numerical was like a little table of values. Graphical evidence means that we'd want to actually include like a sketch here and talk about it. So maybe we can do both. Mm-hmm. So if we go to our calculator and we get rid of what we have in the y equals, and we do 2 and raise it to the x power, if we go to our table, we're always looking at opposite x's and y's. So it helps to be right near the origin. So if I look at -2, I've got 0.25. -1 is 0.5. 0 is 1. 1 is 2. 2 is 4. All right. So right there, I should, if it's even or odd, I'd want to look at a pair of opposite x's. So -2 versus +2. If we look at the y values, there's no pattern here. So right now it's looking like it's probably not even or odd. If we look at it graphically, so I can hit graph so I can take a look at this guy. Our exponential function. We've talked a tiny bit about these, and I keep telling you we'll look at it later in the year, which is true. But it levels off right at the x-axis, and then it kind of shoots on up towards infinity. So the two types of symmetry that you're looking for, y-axis symmetry, which would mean it flips over, not happening. And then in terms of origin symmetry, if I turn this thing upside down, it does not look like the same graph there. All right. And so in this case, we can actually write that, there's no y-axis or origin symmetry. So at this point, what that should support is an answer of neither. This is neither odd nor even. All right, which is fine. Not everything is going to fit into one of those categories. So don't feel like you have to force it. I think the last one that I want to look at here would just be 6. So it's saying a partially filled out table is given below for f of x. Complete the table if f of x is even. So again, you just have to be able to refocus and think, what are the rules? So when it's even, I have x that goes to y, and negative x is also going to go to y. So if you want to think about it in terms of the chart, I could probably squeeze that in here, that x has to go to y, and then negative x would also go to the same y, all right? So you have to look at what you're being given. So to figure out what negative 2 is, I need to focus on what positive 2 is. So if positive 2 goes to negative 1, then negative 2 should also go to negative 1. So these should match. So with that being said, you should easily be able to fill in this last little piece right here. So maybe we'll save that as our little post-video question. Right? Fill in that blank, and then we will chat about the rest of it in class. Thanks for watching, guys.